set of notes, we're going to talk about what's called noble gas envy. All the atoms on the periodic table would love to be like the noble gases as far as their electron configuration goes. So we did these notes as a question of the day, and the first thing I pointed out to the class was, okay, you've got a lithium atom here and a fluorine. What type of bonding is this representing? So this lithium's electron that was once here has moved to the fluorine atom. So right away, because there's a transfer of electrons, that should be a dead giveaway that this is ionic bonding. Now, what happens to the charge on each atom? The protons are yellow in each of these nucleuses, I believe. Let me count on this one. This one might be a little inaccurate here. I'll have to check that. Lithium's got 3 protons, so that's a +3. And it normally has 3 electrons, -3. So +3 and -3 cancel out. But when lithium gives up one of its electrons, now it's got 3 positives and only 2 negatives. So it's got a +1 charge overall. The fluorine, this is supposed to have 9 positives. This might not be quite correct here. I think I'm seeing 10. Okay, so 9 positives, and then it's supposed to have 9 electrons regularly. But this one now is getting an extra electron. So because it's going to have 10 negatives and only 9 positives, this now has a -1 charge overall. So the +1 charge of the lithium attracts the -1 charge of that fluorine. Here's another way to depict it. And here are the overall charges once again. Okay, so ions are atoms that have a charge. We've been through that before. Why do atoms want to form a charge? Well, everything wants to be stable. In class I talked about how, when are you the most comfortable? A lot of people said when they're in their bed, or they're on their couch, or they're in their room. Atoms want to have a full outer shell of electrons. So most of the time that means 8, but for smaller atoms it means 2. They want to have the electron configurations of the noble gases. Hey chemistry class, I've got my eye on you. Gotta keep things light. So big picture. Atoms tend to gain or lose electrons, so they have the same electron configuration as the noble gas that they're closest to on the periodic table. Okay? That doesn't work necessarily for the transition metals. Those are a little bit different, but we'll get to those later. Okay, so what does this mean? Let me quiz you a little bit using this periodic table. What noble gas is sulfur closest to? Well, it's closest to argon because that's 2 to the right. Just as a refresher, these are the noble gases in this last column. Okay, so what about magnesium? Which noble gas is magnesium closest to? It's closest to neon, number 10, because that number 12 is closest to number 10. Okay, what about something like aluminum? You might get tricked up and want to say argon, but that's 5 away. So aluminum is actually closer to neon. And then everything in carbon's group here, they can go either way. Carbon could gain 4 electrons to be like neon, or it could lose 4 electrons to be like helium. So there's a pattern on what charge these atoms will form. So for example, everything in group 1A, they would all like to lose 1 electron. So when they lose that negative charge, they're going to have more protons than electrons by 1. That means their overall charge will be a +1. All of these want to lose 2 electrons. So they form a +2 charge. I always say it like this. If you have 2 negative people in your life and you lose them, you're going to be more positive. Like when magnesium loses 2, it'll only have 10 electrons like neon, so it will still be a magnesium because you haven't changed the number of protons, but it will have a +2 charge. Everything in this boron group likes to form a +3 charge and lose 3 electrons. Like I mentioned before, this group in the middle can go either way, plus or minus 4. Everything in nitrogen's group would like to gain 3 electrons. Everything in oxygen's group would like to gain 2, so they form a minus 2 charge. Because again, if oxygen gets 2 extra electrons, it's still going to have 8 protons. So it's going to have 2 more negative charges overall. Everything in fluorine's group forms a negative 1 charge, and the noble gases don't form any charge because they're already perfect, so they stay the way that they are. These are called oxidation states, by the way. And here's the group numbers with Roman numeral form, and it spells out what I was just talking about with the last picture. Just a review of the terms, cation versus anion. These were also in the last set of notes. Cation is positively charged, and an anion is something that's negatively charged. So you could go back and say, okay, what is magnesium a cation or an anion? And it's a cation because it forms a +2 charge, versus something like oxygen would be an anion because it forms a -2 charge. Another little joke for you. And I introduced this term in the last set of notes, but what is a lattice again? Pretend like, okay, this isn't the best example, but here are a whole bunch of carbon atoms. And here they are again, they're in a slightly different conformation. Here they're in diamonds structure, and here they're in graphite structure. So basically a lattice is just something where you've got a lot of atoms that are repeating. A formula unit is the simplest whole number ratio of ions that are represented in that lattice structure. For example, what if this cube had 161 sodiums and 161 chlorines? What's the simplest whole number ratio? Well, it's 1 to 1. There's 1 chlorine atom for every sodium atom. So the simplest formula unit would be NaCl, 1 Na and 1 Cl. Another example that I had in the notes was, what if you had 10 magnesiums and 20 chlorines? Well, that would be a 1 to 2 ratio, and the formula unit would be MgCl2. When you're talking about covalent things, you don't talk about formula units, okay, because they're not ionic, they're different. So the smallest particle of a substance in that situation is called a molecule. Finally, there's some different terms, monatomic and polyatomic. Monatomic, mono means 1, so it's a single atom that has a charge. Polyatomic is when you've got a whole group of atoms and they stay together. They kind of act like a single element in that way, but they have an overall charge. The ones that you guys have to memorize, here they are: sulfate, phosphate, nitrate, hydroxide, ammonium, and carbonate. Those are the 6 that you need to know for your quiz. So here's a short little quiz on monatomic or polyatomic. Cl minus, that's just 1 element with a charge. So that's a monatomic ion. OH minus, that's 2, oxygen and hydrogen, so that's polyatomic. This is a trick. This doesn't have a charge, so it's neither. Same with H2O. Carbonate, CO3 with a -2 charge, that's polyatomic. And then finally, this would be another monatomic. Calcium is 1 atom. And that is it for the